So here question number 33 of GATE 2018 of Civil Engineering afternoon session is discussed. Question is, an 8 meter long simply supported elastic beam of rectangular cross section is subjected to UDL or uniformly distributed load of 10 kN per meter over its entire span. The maximum principal stress at a point located at the extreme compression edge of a cross section and at 2 meter from the support is. So this is what we have to calculate. So student has to recall the concept of principal stress and accordingly he has to solve this particular problem. So difficulty level is somewhat difficult since student has to solve this particular problem within a minute or two. So question setter wants to know whether student can solve this kind of question with a short period of time. So length of the beam, that's L equals to 8 meter, while dimension of the beam are given as 100 mm by 200 mm, width equals to 100 mm and depth equals to 200 mm. While UDL, that is W, equals to 10 kN per meter, maximum principal stress at a point which is located at the extreme compression edge of cross section and which is 2 meter from the support. This is what we have to find out. So if we just see this diagram where we can easily see this particular beam having a UDL of 10 kN per meter, and we have to calculate this particular stress at 2 kN or 2 meter from the support. So let us take it from the left hand support, section X, which is having a particular beam having a length of 8 meter. So simply we have to take the moment about point X. If we just take the moment about point X, so it's very simple moment calculation, that is equals to mx equals to minus VA. So reaction at support A point multiplied by its distance 2 plus W UDL multiplied by 2 into 1. So that's 2 by 2. So now we have to calculate the reactions, that is VA plus VB is equals to 10 over its entire span. So 10 multiplied by 8, that is equals to 80. Now since symmetrical loading, so twice VA equals to 80. So we'll get reaction at support point A and point B, that is equals to 40 kN each. So this particular equation, this particular value of VA is to be put here, and we'll get mx equals to minus 40 into 2 plus W, that is 10 into 2 multiplied by 1, that is equals to minus 60 kN meter. So once we calculate the moment at X, now we have to check formula for stress in bending, that is sigma equals to m by I multiplied by Y. So m, value of moment which we have just calculated, 60 kN meter. So we just convert it into Newton mm, so that is 16 10 to the power 6, and that divided by I. So since it's rectangular cross section, so that is equals to BD cube by 12. So this is B, this is your D, and now this Y equals to D by 2. So this is 200 by 2. That is coming out to be 90 MPa, or 90 Newton per mm square. Now since direct shear stress tau equals to 0, so we can say the maximum principal stress at a point which is located at the extreme compression edge, that is equals to 90 Newton per mm square. So this is the final answer. So in this particular problem, student has to take just the moment at particular section XX. He has to calculate the reactions at support point A and B. Once he calculated it, he has to put those particular value into the equation of moment. Now for stress in bending is the formula, that is sigma equals to m by I multiplied by Why? Now you have to consider the particular units properly. You have to insert the units properly. So value of m, I and y. Once you insert those things, we'll get the stress in bending. Now since we know this concept, so direct shear stress, once you know that tau equals to 0, so we can from consider that maximum principal stress, which will be 90 MPa. That's the final answer.